Okay, so welcome back. So now in this example, we're going to use partial fractions, and we're going to decompose this into a sum of other simpler fractions that we can more easily integrate. Okay, so notice first of all the degree of the top is less than the degree of the bottom, so we don't have to do any long division here. And so we're going to factor the bottom, and so we can see that this factors nicely. Okay, so we've got a greatest common factor of x. And then we can see that this factors also nicely into two other factors, right? So again, you should be able to see that this is nice. So this equals, right? So the two factors are going to be what? -2 and 1. -2 and +1. So then we rewrite this as 3x minus 2, this is going to be x times x minus 2 times x plus 1 dx. So the next thing is now we're going to use the fact that we can rewrite this as a sum. So there has to exist, right, constants such that the following must be true, right? So we know we should be able to write this as x. Now, to see that this is a linear, right? This is a linear factor, is to write this and just to in your mind's eye, think of this as x plus 0, right? So this is a linear factor. Okay, so just keep that in mind for as we get further on and we start getting to nonlinear factors, because that's where students will mess up, is they'll treat this as a nonlinear factor, especially when we start mixing these up, which will be coming soon. Okay, so now let's stick with this. So we've got this, and so now by the fact that we can break this down, we know that we should be able to find, since this is factorable, we know we can find factor or constants such that this must be true. Oops. Okay, so then the question becomes, well, how do we find that? Well, this is where the technique comes in for finding the constants, okay? And so what we have to do is we have to get a common denominator, because we have to make these look like this. And if we do, what will happen is we'll get an expression on the top that must be equal to this. So let me explain that again, okay? So we've got this has to be equal to this, right? So what we want to do is we want to set this equal to another expression that involves A, B, and C, where we can solve it. Okay? So, what I'm going to do is I'm going to make all of the denominators into this one. Because if all of the denominators are equal, then I know that whatever I get on the numerators, these must add up to equal this numerator. Right? By just the idea of adding like or adding fractions. Think of adding fractions with common denominators, right? You add across or subtract across the top and keep the bottom. So that's what we're doing. So we're going to make the bottom the same. We're going to make these three denominators equal to this. And then we know that if we add across the top, we should equal this. Okay, that's the idea. Okay, so that means we're going to multiply by the least common multiple, which is going to be these three. And we're going to add across the top. So what does that mean? Let's do some scratch work. Okay, so what I'm going to do is I'm going to write 3x minus 2 over x times x minus 2 times x plus 1 equals a over x plus b over x minus 2 plus c over x plus 1. Okay, so there's my equation. So now what I'm going to do is over here, I'm going to make these denominators equal to this one. So I'm going to have to multiply the top and the bottom by these two over here. Okay, so what happens is I'm going to get a times x minus 2 times x plus 1 over x times x minus 2 times x plus 1. So right, I just rewrote this one like that. And now I've got x minus 2, so I need an x and an x plus 1. So I'm going to multiply x and x plus 1 times b. Okay, and now I'm going to do the last one, c. C has x plus 1 here, so I'm going to multiply by these two. So I'm going to say I have c x times x minus 2 over x times x minus 2 times x plus 1. So now look what I did. I got this to be the same over here, and now I know that the numerators must add together. So this plus this must equal this numerator. Well, guess what? That's my equation. So here's what I'm going to do. Now I'm going to continue with my scratch work, but I'm going to erase some of this stuff. Okay, so I'm going to go back to here, and I now am going to write so now I have 3x plus 2 has to equal a times x minus 2 times x plus 1 plus bx times x plus 1 plus cx times x minus 2. So that's my equation now. So now all I have to do is solve for a, b, and c. Now, that's the tricky part. Okay? So now watch what I'm going to do. I'm going to simplify this. I'm going to expand this out, and then I'm going to combine like terms. Okay? How am I going to combine like terms? I'm going to combine like terms by x. Okay? I want this side over here to match this side. So watch what I'm going to do. So I'm going to just distribute and simplify by combining like terms. So this is going to give me x. So these two are going to give me x squared minus x minus 2. This is going to give me bx squared plus bx plus, this is going to give me cx squared minus 2 cx. And then again, I'm going to go ahead and distribute. So that's going to give me ax squared minus ax minus 2a plus bx squared plus bx plus cx squared minus 2 cx. So now what I'm going to do is I'm going to group the x squares together, the x's together, and the constants together. So I've got an x squared here, an x squared here, and an x squared here. So I'm going to put those together. And then I'm going to put the x's together. So I've got a minus, ax, I've got a plus bx, and I've got a minus 2x. So I'm going to write this as bx minus ax minus 2 cx. And then I've got a minus 2a, a b, oh that's it, just minus 2a. So this is going to be minus 2a. Okay, so now, why am I doing that? Because, again, I want this to match over on this side, okay? Or the other way around, I want this side to match this. So now what I'm going to do, I'm going to factor out the x squares and the x's and group the constants together. So this is going to equal a plus b plus c times x squared plus b minus a minus 2c times x minus 2a. And now what that does is it gives me a system of equations that I can solve. Because now I know this has to equal 0 because I have nothing here, right? So what I have, if I match this up, I have 0 times x squared plus 3x plus 2. So that tells me this coefficient here equals this coefficient here. Right? And this coefficient of the x has to equal this coefficient here, which is 3. And then, of course, this constant has to equal this constant, which is 2. Okay? And that's what we're going for. Okay, now, let's set up the system of equations and solve for this. Okay? So again, this is still part of my scratch work that I'm doing. So now, I know that what? A plus b plus c has to equal 0. B minus a minus 2c, so if I have a negative a here, right? So b minus negative a, or excuse me, b minus a minus 2c, so I just flipped it, made this negative a, plus b minus 2c has to equal 3. And then negative 2a has to equal 2. Okay, now I'm going to solve for a, b, and c, and I'm done. So here, since negative 2a has to equal negative 2, well, that gives me what? That tells me that a is equal to negative 1. So I've got one of them. And now I can plug in negative 1 into these two, and I can get a system of two equations with two unknowns that I can solve. So now I'm going to write these two as negative 1 plus b plus c equals 0. And this is going to be positive 1 because it's minus a. So minus the negative 1 is positive 1 plus b minus 2c equals 3. And so now what do I get? I get b plus c equals 1, and I get b minus 2c equals 2. And so now if I multiply the top by 2 and then add these, what do I get? So here I get 2b plus 2c equals 2. And if I add down, I get 3b, the c's go away, and I get 4. So I get 3b equals 4. And then I just solve, right? So then b equals 4/3. So now I've got two of them. So now all I have to do is take a and b and plug it into either this one or this one. So I'm going to plug it into this one. a plus b plus c equals 0. Okay? And so now I know that negative 1 plus 4/3 plus c equals 0. Okay, well I can change this into 3/3. And so this is going to give me 1/3 plus c equals 0, which then tells me that c equals negative 1/3. And I've got the third one. Okay, now all that work to figure out a, b, and c, which it wasn't hard, it's just, it can be tedious. So now I know that a is negative 1, b is 4/3, and c is negative 1/3. And so now I can solve the problem. Okay? So now, look what happens. Now, this, so this negative 1, I can deal with this. So this becomes negative the natural log of the absolute value of x plus, same thing, I could pull the 4/3 out. This becomes 4/3 times the natural log of the absolute value of x minus 2 plus, or minus, I should say, minus 1/3 times the natural log of the absolute value of x plus 1 plus my integration constant of integration c. Okay. Okay, so now, what we're doing here is using one of the, there are two strategies that we can use to solve these. Okay, there's the method of equating coefficients. That's what we just did. Now, this method here works every single time. Okay, bar none. It will always work. It's a little tedious. It's a little time consuming, but it will work. Okay, now, the other method I'm going to show you next, how to solve this, is called the method of strategic substitution. You're substituting in such a way that it makes things much easier to find A, B, and C. Okay? So let's try that one. Okay, so if we look at this here, okay, or actually no, let's look at this here. Let's go back to A, B, and C. So now what I'm going to do is, this is the method of strategic substitution. Okay, so now what I have to do is I have to choose a substitution for x that will make this solve very easily. Okay, so how would I do that? Well, I go back to my setup. Okay, so you get the equation. Okay, so let's see how this works. Let me just write the equation back up here. So 3x plus 2 equals let's see here. Oops. Let's do. Okay, so let's go back to this equation here. Okay, so at this point here, we can use strategic substitution. So how do we use strategic substitution? Well, we're going to, this has to be satisfied for all values of x. All values of x. So that means we could choose values of x that will make this thing much simpler to solve. So typically what we want to do is we want to eliminate all of the variables except for the one we want to solve for. So we have A, B, and C to solve for. Those are the unknowns. So let's choose values of x that will eliminate 2 of the 3 unknowns and then solve for the one that's left over. Well, the easiest way to do that is pick a value that will make 2 of these terms 0. For example, if I make x equal to 2, right? So if x is equal to 2, what happens to this term? This term goes to 0. This term goes to 0. And I end up with this term. Well, what happens over on this side too when x equals 2? That's the other thing too. When I plug in this side, what do I get? I get 6 plus 2, so I get 8 equals what? B times 2 times 2 2 plus 1, right? Which then gives me 8 equals what? 6b. And I divide both sides by 6. I get b equals 8/6, which simplifies to 4/3. All right. So now what about getting one of the others? Well, okay, let's make x equal to -1. If x is equal to -1, what happens? So let's do x equals -1. So if x is equal to -1, then this goes to 0, this goes to 0, and I end up with c. But before I do that, what happens over here? If x is -1, I get -3 plus 2, which is then -1, equals c times -1 times -1 minus 2, which then gives us what? -1 equals, well, this is -3 times -1, which is +3, right? And then, of course, if we divide both sides by 3, that gives us c equals -1/3. All right. And then finally, we want to solve for a, right? Well, we want to get rid of this 2. So we're going to make x equal to 0, right? Because if x is equal to 0, this term and this term goes away and we end up with this term. So if x is equal to 0, what do we get? Well, over here we get 2. Oops. Okay. 2 is equal to what? Well, this just becomes -2, right? So this becomes a times -2 times 1, which gives us 2, right? Same thing we had before, which is 2 equals -2a, which then gives us that a is equal to -1. And we get the exact same result that we got before. Okay. And that's it. Let's see. Okay, so one warning. If you do use the method of strategic substitution, make sure that your equation is set up correctly, okay? Because if it's not, then you can still solve for the constants, but they'll be meaningless, okay? So if you do opt for doing the method of substitution, one, make sure it's set up correctly, but also make sure that you check algebraically that those constants do work, okay, by combining things, okay? But that's it. So either way is fine by me, and it'll get you the correct answer. Obviously, this is going to be a faster way of doing it, okay? But if this doesn't work or you get stuck on this, you can always go back to just solving the numerators like I did before. Okay? See you next time.